Good evening and welcome to my channel. Tonight we are going to be taking a look at the Auger Lift that I've been working on for my MMR FOS. That is my massive marble run from outer space. It is going to be a science fiction based marble run with robots, hopefully moving robots. And this is the first time that I'm going to be incorporating DC motors and LED lights into a project, and so I've been learning a lot as I've been incorporating those into the project. The whole idea is that the marble run is going to be self-contained. You'll be able to remotely turn it on, have it run for a certain number of minutes, and turn off automatically, and not have any hand cranks or anything. So it's all going to be ran off of a deep cycle marine battery, a 12-volt battery. At least that's the plan for now. That's what I've been testing it with. And the LEDs that I've incorporated into this, I started out with 3-volt LEDs, and now I moved those to 5 millimeter 12-volt LEDs. They give off a bit more light and you can see them better. And I'm incorporating different types of motors into this for the different movements. My plan is to have not just the rotation that you get from some of the motors, but I am planning on using either some step motors or another type of motor so that I can actually control the movements of some of the robots. So that's going to be fun and interesting as I dive into that. But for tonight, we are looking at just the Auger Lift. I needed a way to get the ball bearings from the lower parts of the marble run up towards the top and get them started on a track and then have them go. They'll be going to the gravity well and doing other interesting things, but they need to be up here to get down there. And so I needed a way to do it that was fairly compact, reliable, not a lot of moving parts, able to lift a large number of the ball bearings and have it done at a steady rate and not choke out the motor. And so I saw some different examples of the auger, people using augers to move ball bearings around, and so I thought I would try that for this, and so far I've been really pleased with it. It didn't come without a number of challenges, and I'll talk about some of those as we walk through the different pieces and parts and the design of this. So, but without further ado, this is mostly complete. It's working. I don't have it glued together yet. I did want to do this video and show you some of the inner workings before I actually glued some things down. Not everything is going to be glued down. Some parts are held together with magnets. Other parts I am going to attach with screws so that I can, if need be, I can unscrew them and get in and do maintenance on this. One thing you don't want, for instance, this part has a DC motor. If that DC motor were to fail and I had glued everything up, I would have to basically break the thing or bust into it in order to fix it. I don't want to do that. So I'll show you how I allowed myself access to the motor. So let's go ahead and start taking a look at the inside and design of the Auger Lift. So for now, looking at the outside, again, I don't have this glued up yet, but I've got the top part here, and I'll come in for a close-up later and show you what I did there. This is the cap, and then this section here is where the ball bearings are going to exit, and I don't have this glued in yet. It will be glued in, but for now it just slides on, and you can see where the ball bearing is going to come out and then follow the track down. You have the auger here in the middle, and then this piece right here I added for additional stability, and also I don't have any wires coming up through this main part, so I'm running wires and so I can power LED lights in this section. Again, it's not glued up, so just going to go ahead and pull this off. Yeah, not necessarily simple. There we go. All right. And I did add some glue in here just to keep some of the pieces in place. And so, but this right here, maybe you can see, we'll get a close-up later, but you can see that this has LED lights coming out. I did these in parallel so that if one of the lights fails, the others won't fail. And so that's going to be attached to this. And then on the side of the shaft here, there's 3 separate holes in. So these are for where the LED lights are going to shine into the auger shaft. And go ahead and pull this off. And again, we'll get another close-up later on. But within these holes, I added some epoxy, and that diffuses the light a little bit from the LEDs. They were shining pretty brightly, very brightly within this, and I wanted more of a diffuse light, so put in some epoxy, and that really seemed to do the trick. There's that. And then we'll do a close-up to look at some of the other. So here you can see the main shaft, and this is made, each of these pieces are, I carved out on my CNC. These are all beech wood, European beech. And with this base piece here, this is black walnut. And look through the center of the shaft. There it is, and you can see. So this section right here, that's where the ball bearings. That's the track where the ball bearings are going to come up. I did already put some wax in the middle of the shaft, on the inside of the shaft, to help with the auger movement, and it quieted it down a fair amount. On the base, one of the challenges I had was actually getting the ball bearings up into. Once they're in the auger, no problem. They go up. Hey, Dixie. Hey, you're on K9 camera. All right. Once they're in the shaft, no big deal, no problem. But getting them to actually engage with the shaft, that was a bit of a challenge. And so I had to do a couple of things here. One was the section leading into the shaft, into the auger, was all one level. And what I found is I needed just a little bit of a lift. So I added some epoxy there so that when the ball bearing comes through, it'll lift up a little bit. So the ball bearing is going to come and it's going to hit that little slope and be drawn up into the auger shaft. And then on the inside of the shaft, where that happens, I've actually got a rare earth magnet, and this part right here, let's see if I can get a better picture of that. So I don't know if you can tell, but this part right here is kind of curved, and so when the ball bearing comes in, it's going to be attracted to the magnet, and the magnet's going to pull it to itself, and then it's going to kind of run up that curve, and when it gets on top of or is attached to the magnet, at that point it's close enough to the auger that it goes ahead and pulls it up. Okay, so now I've got one of my 5/8 ball bearings, and oops, one's escaping over here. And so what's going to happen is the ball bearing is going to roll up and be pulled up by that magnet. And at that point, it's going to be close enough to the auger shaft that the auger shaft is going to pull it up there. And I think that looks like a little face right there. So didn't mean to do that, but there it is. When the ball bearing comes in, so it's going to roll down this little slope here and get picked up by the magnet. And then at that point, when it comes up to the magnet, it engages with the auger, and so when the auger spins, it goes ahead and pulls that up. So that is how that works. So if I go ahead and pull this off, you can see the ball bearing there on that magnet. So it works pretty well. So there's the shaft part. One of my goals with this was so that it was as easy to maintain, or maybe not impossible to maintain, if for some reason the DC motor were to fail or I had to do some maintenance on it, I need to be able to get to it. And so instead of gluing this on, I put, again, more rare earth magnets where the different parts of the, some tape there left over, where the different hold downs for the DC motor at. So I don't have to glue it down and just lift this up, and the magnets help keep it down. And then I did put a section in here, kind of carved out a little bit of a section where the wires come up for both the motor and for the LED lights. The motor is attached with 3 little screws. And so again, if I need to get to it, I can. And so let's go ahead and pull up the base here, and you can see how I have that. Go ahead and lift off the shaft, and we'll set this to the side for the moment. And so this piece of plywood, 3/4 inch plywood, and I used my CNC to cut out the section for the larger gear, which drives the smaller gear. And I did, it's not 2 to 1, but it's close. So this basically doubles the speed of the shaft. This DC motor runs at 25 RPM. And so with the gear ratio, it bumps that up close to 50 RPM for the auger. And one of the challenges I had was that this is a larger gear, and let me go ahead and kind of pull it off here if I can. There we go. All right. So this is larger, and so what happens is when I put pressure down on this, it would have a tendency to kind of go back and forth and not stay level. So I decided to cut in a groove and put in these little 1/2-inch ball bearings. And so the gear actually floats on those bearings, and the bearings keep this gear from kind of moving back and forth, and so it stays level. And then my second gear here that I have, I just have it glued to the bottom of the auger shaft, and you can tell, I waxed this part, put wax on here. Still need to do the rest. This fits in right here, and so you can just see, this drives the auger, and that's how that works. I did have a bearing here, and had it attached to a dowel to the base of this, but actually it works better not attached to that bearing. It actually works better if it's got a little bit of wiggle room in there. So let me go ahead and put the gear back on. So I just cut a hole to fit the shape of the DC motor shaft there, you can see. And then I also cut a little window here so I can watch the gear as it turns. And I was doing some troubleshooting with that. It looks kind of cool, actually being able to see that in there. So I'll just insert that back on and actually loosen it up just a bit because I want it to kind of press down on the ball bearings. Go ahead and put the auger shaft back in. Actually, before I do that, I'll talk a little bit about the auger shaft. So this was a real challenge. I did this on my CNC. I do not have a rotational device on my CNC. So what I did is I mounted this on, made a little mount for it, and then had actually that DC motor on the end, and had the piece, I put it on my lathe and kind of smoothed it out so it was a circular cylinder. And then I had the DC motor turn at a slow rate, and I ran the CNC, had it actually move at a constant rate up the shaft several times, and each time went down a little bit further until I got this shape, and it came out really nicely. Go ahead and put that back in, and actually do it like this there, and so you can see how that works. And now put that on there and put our, and I need to clean up some of the wires there. I've got one set of wires are powering the DC motor, and I'm going to have a control separate for the motor so that I can do the lights separate from the motor, because sometimes you want to work on the motor, sometimes you want to work on the lights. Go ahead and need to make sure when I put this on that it's actually where the wires are at. So we'll do that. Get this guy back on there. And voila. Use there. Go ahead and put our shaft back on. And again, this isn't entirely complete. I've still got some sanding and tweaking to do, but you get the idea. The other piece I wanted to kind of show is when the ball bearings exit, I actually had to create a little lip here, which it's kind of hard to explain, but when the ball bearing came up, it needed to be pushed out. And so this little lip here actually forces the bearing out along with the top of the shaft here. So it's when it rotates and comes around, it helps push that ball bearing out. And we'll get a video of that. I hook this up to some power. And basically that's, this is the inside of the cap. And I had to kind of carve out this section here so that I could have the top of this shaft go out a little bit further so it would knock the ball bearing out. But it just goes on like this. So this is one of the tests I ran as I was working on putting in the LEDs and also testing just that the auger worked properly. And you can see that I've got it hooked up to a little 12-volt battery that actually came with my handheld screwdriver, and I've been using it extensively in the development of this project. And so I'm hooking up the LEDs as well as the motor to that battery, and just verifying that the LEDs work properly and the auger actually does what it's supposed to do, which is to draw up the ball bearings up the shaft and have them exit out on top. This is another test that I ran on the Auger Shaft, just verifying that it is picking up the ball bearings like it's supposed to, and that the lights are running properly. The Auger Lift is attached to the main table. You can see the big gravity well there in the background, where that's actually where the ball bearings are going to be going once at least in this portion of the video, at this point in time, I don't have the full ramp going on to the gravity well. That'll be added later, but that's the intention, is that this is going to feed the gravity well, which will feed the other portions of the marble run. Here's another video recording. The marble run is just about complete, and you can see everything, most everything, working together like it should, and all the bar bearings being pulled up by the auger and coming out and feeding into the gravity well. I hope you have enjoyed this video and that it's been interesting to you. And if you derive some benefit from it, you enjoyed it, I would ask that you hit like and subscribe. It definitely helps me out. It definitely motivates me to continue creating this kind of content. And wishing you all the best. Take care and good night.